So how many days are left out, beta? 7 days. In 7 days, how do you prepare in the 5 days of the last part of this one? These topics to be covered and how much part of the revision you need to do and which are the scoring topics where you can take care. Okay, na?
Yes, sir.
Last 5 days. First thing is, you give more importance for your modern physics. Easy topics and scoring topics better. In this one, you first try to revise all the formulas of your dual nature of your matter. Then you revise your atoms. Then you revise your nuclear physics. Damn sure there are 2 questions from this one. Better. 2 questions means how many marks? 8 marks.
8 marks.
The next one is modern physics 2. Modern physics 2. This is a modern physics 1. In modern physics 2, you need to study about your X-rays. You need to study about your semiconductors and devices. And you need to study your logic gates. X-rays we may or may not be getting better, but semiconductors and logic gates we may be getting 2 or 3 questions from this one. On a rough, if I am taking even 2 questions, again this is a weightage of your 8 marks. Okay. The third one,
Sir.
you prepare for your units and dimensions and errors plus instruments. Okay. Instruments means your screw gauge and vernier calipers. Damn sure you need to visit better. Again, this is having your 4 marks weightage. Small topic, damn sure 4 to 8 marks. I'm taking the least mark in this one, that is nothing but 8. Okay.
Yes, sir.
The next one is you revise your gravitation. Again, damn sure 1 question from the gravitation, that is your 4 marks. And next one is you revise your KTG plus your thermal properties of matter. Thermal properties of matter. Thermal properties of matter means solids, liquids, direct formula based better, and gases. And one more topic in this one is calorimeter, direct formula based topic. Okay. And with this one, you need to even revise your thermodynamics, plus heat transfer. Okay. So in this one, 2 to 3 questions better. 2 or 3 questions from this one, roughly.
Yes, sir.
In this one, so we will be getting again your 8 marks weightage. What an idea?
Yes, sir.
Total engineering. Here I'm taking this one 8 marks into consideration. By studying
24.
Isn't it?
Yes, sir.
So this is your 8 plus 8, 16, 16 plus 4.
28.
20, 16.
28.
4. How much?
28,000, sir.
16 plus 4 marks beta. 20 కదా?
దాని తర్వాత ఇది KTG థర్మల్ ప్రాపర్టీస్
దాని తర్వాత In this one, I have not written everything. Again, this one is 4 marks, gravitation. That is 24. 24 plus of your 8. How much?
2.
I'm audible better. How many
32,
marks?
sir.
32
32.
marks. Okay, this is from your minimum topics. Okay.
Yes, sir.
దాని తర్వాత if you have been done this one అంటే you need to revise these topics daily కనీసం నువ్వు దీనిపైన you need to keep 1 to 2 hours of your revision only form list, no in depth of the study. Dual nature, de Broglie wavelength, Davison's experiment, atoms, how to calculate impact parameter, how to calculate the energy levels at all, nuclear physics law, how to calculate the beta plus beta minus K capture, that all things you need to revise it in this one effectively. Got an idea?
Yes, sir. Yes, sir.
Isn't it? ఈ విధంగా కొంచెం మీరు రివైజ్ చేయగలిగాం అనుకో 32 మార్క్స్ వస్తాయి.
Yes, sir.
ఇంకా నేను చాలా టాపిక్స్ ఇంక్లూడ్ చేయలేదు విచ్ యూ కెన్ డూ ఇట్ ఆన్ యువర్ ఓన్ ఆల్సో. ఓకే, ఫస్ట్ ప్రిఫరెన్స్ ఇది ఇచ్చేస్తే మీకు 32 మార్క్స్ లో 30 మార్క్స్ వచ్చినా కూడా దట్ ఈస్ మోర్ దాన్ ఎనఫ్ ఫర్ మీ. అంటే సెకండ్ ఇయర్ లో ఇంకా కొన్ని టాపిక్స్ చేసుకుంటుంటావు నువ్వు, isn't it? Like communications and systems la, electromagnetic waves, isn't it?
Yes, sir.
You can even directly go for the formula like TV antenna formula, ranges, NCRT నుంచి చదివి కొంచెం PYQs చేసుకున్నా కూడా you can do some problems on your communications and devices.
Yes, sir.
Isn't it? This is also your 4 marks weightage. Small topic. The next one is about your electromagnetic waves. Again, this one is your 4 marks. Directly formula based question, small topic, NCRT la 2-3 pages lo undante. Okay.
Yes, sir.
Next one is your current electricity. Current electricity, you need to revise it. You will be getting 3 questions from this one. On an average, 2 and 3 questions eskunnadu kuda, the weightage of this one is 8 marks to 12 marks.
Yes, sir.
So entaina chudu, idi 8, idi 8. I'm taking 8 marks only in this one. I'm not taking the 12 marks. 8 and plus 4 plus 4, 8. 8 plus 8 is how much for me? 16. This 32 plus of your 16. So how much it is? 48 marks.
Yes, sir.
అవునా కదా? స్మార్ట్
Yes,
గా
sir.
రోజు కొంచెం టైం తీసి చదవగలిగితే ఒకవేళ if you are able to get 48 marks in physics, 50 marks in your chemistry, 50 to 60 marks in your physics, in your mathematics, ఎంత అవుతుంది స్కోర్?
150. Around 150, I think.
ఇదెంత? 8 5 plus 6 11 11 plus 4
158 అవుతుంది, sir.
158 marks. 158 marks అంటే is very good score. Very good score in last days of your preparation. First attempt నీకు ఇన్ని మార్క్స్ వచ్చాయనుకో, you can shift for your then second attempt పైన కాన్సన్ట్రేట్ చేసుకోవచ్చు. Minimum 158 వచ్చాయంటే you will maybe somehow somewhere you will be getting NIT seats. అవునా కదా?
Yes, sir.
See how easy it is. In 5 days, 6 days, నువ్వు కొంచెం కష్టపడగలిగితే, if you can read out for some days, you can easily get this many of much of marks. Okay. So dual nature, atoms, nuclear physics will not take much time because atoms is same as that of your chemistry. Nuclear nature is dual nature is also same as of your chemistry. Photoelectric effect, de Broglie wavelength. Nuclear physics, you need to concentrate on radioactivity, nuclear fission fusion, beta plus, alpha decay, beta decay, and gamma decay, nuclear power reactor, that all problems.
Yes, sir.
చేస్తావా?
Yes, sir.
సీరియస్ గా స్టార్ట్ చేస్తే యూ కెన్ ఈజీలీ డూ ఇట్ అవుట్ బెటర్. పెద్దగా ప్రాబ్లం ఏమీ ఉండదు.
Yes, sir.
అర్థమైంది కదా స్కోరింగ్ ఎంత ఈజీగా ఉందో?
Yes, sir.
సో ఈ లాజిక్ బట్టి నువ్వు ప్రకారం ఇఫ్ యూ కాన్ స్టార్ట్ యువర్ ప్రిపరేషన్ యూ కెన్ ఈజీలీ గెట్ సమ్ గుడ్ స్కోర్ బెటర్.
Yes, sir.
చేస్తావా?
చేస్తాను, sir.
న్యూక్లియర్ ఫిజిక్స్ ఎక్కడి వరకు అయింది చూడండి సరే. Nuclear reactions, I told you how to write a nuclear reaction better. Initial nucleus plus attacking particle will always gives an end product and also an emitting particle. Force between electrostatic force and nuclear force, if they are same, then the nucleus will be in the stable. On a nuclear
Yes, sir.
force is a strong attractive force and strong in the very short in the range. What are the nuclear forces? And force between neutron, force between neutron and proton, force between proton and proton are known as nuclear forces. Okay, an element is represented.
Yes, sir.
Above one is known as mass number, below one is known as of your atomic number.
Yes, sir. Yes, sir.
The nuclear size. Basic formula of a nuclear size, I told you that size of nucleus is directly proportional to your atomic mass. So volume of the nucleus 4/3 pi r cube is directly proportional to A. That means R is equals to R naught A to the power of 1/3. R naught is known as Fermi constant and the value of R naught is 10 to the power of minus 15 meter. If radius, nuclear force decreases. So when radius is increasing, nuclear force decreases, the nucleus will become unstable and starts decaying. That means this stable nucleus will decay into Y by giving certain amount of radiations in the form of alpha, beta, and gamma. Got it? The value of
yes, sir.
How much Fermi? 1.2 Fermi. I told you it is 1.2 into 1 Fermi is 10 to the power of minus 15 meters. Now, what is the relation between the radius and as well as of your mass number? Means it is right now for me R1 divided by your R2. R1 divided by your R2 is equals to your A1 divided by A2 to the power of 1/3. Or A1 by A2 is also directly proportional to your mass. That means it is mass to the power of your again 1/3. Isn't it?
Yes, sir.
As the nuclear force is an internal force beta, so no external forces have been acting. So momentum is conserved. If momentum is conserved, initial momentum will be equal to your final momentum. So M1 V1 will be equal to your M2 V2. So M1 by M2 will be equal to V2 by V1. Or else from this one I can write radius R1 by R2 is equals to M1 by M2 to the power of 1/3. In the place of M1 by M2, I can write your V2 by your V1 part. So R1 by R2 is equals to your V2 divided by V1 to the power of 1/3. Got it?
Yes, sir.
Sure. So ultimately, what is the relation I got right now, beta? R1 by R2 is equals to your A1 by A2 to the power of 1/3. That is equals to M1 by M2 to the power of 1/3. Or that is V2 by V1 to the power of your 1/3. V1, V2 are nothing but what? Velocities. The next one I told you about is nuclear binding energy formula. The energy required to separate an atomic nucleus completely into constituent protons and neutrons is called as nuclear binding energy. Or equivalently, the energy that would be liberated by combining the individual proton and neutron in a single nucleus is called nuclear binding energy. Like see here, when proton is been combining with neutron, we are getting an element, we are getting a nucleus, a stable nucleus, and along with that one certain amount of energy has been released. That releasing energy is called as what? Binding energy. So if I'm writing a note here, whenever reactants are combining to form a stable product, there is a mass loss. That mass loss is known as mass defect. So what is the mass defect formula, beta? Delta M is equals to Z into your MP plus A minus Z into mass of neutron minus mass of nucleus. So mass defect means mass of nucleons minus mass of nucleus. Nucleons means what, beta? Proton plus neutrons. Now how do you calculate the binding energy? From the Einstein's mass energy equivalence, EB is equals to delta M into C square. If delta M is taken in your AMU, one AMU will be equal to 1.66 into 10 to the power of minus 27 kg. I can write directly binding energy is equals to mass defect into 931 MeV. If delta M is given in AMU, just multiply with 931, you will get the answer. Okay?
Yes, sir.
So, binding energy per nucleon. Binding energy per nucleon means binding energy per atomic mass. It tells how the stable is a nucleus, isn't it? Binding energy is low in the for it is low for all the atomic number masses lesser than 30. All the elements whose mass number is lesser than 30, binding energy is lower. And all the elements whose mass number is greater than 170 or also the binding energy is lower. Okay? So greater the binding energy, greater will be the stability of your nucleus. And most stable element in our periodic table is your iron beta 56. All the higher elements will try to break to become a stable of your iron, and all the smaller elements will try to combine to form a stability of an elements. So they are the stable between 50 to 100 in the range elements are the stable part. That is the reason higher elements will try to break. That is called as of your fission, and the lighter elements will try to combine. That is called as of your fusion. Okay.
Yes, sir.
Nuclear fission and fusion, I told you. Fission means splitting. An element X, and heavier element will split into your Y plus Z with the elimination of a certain amount of energy. In the place of fusion, we are joining of a nucleus. When two elements are been combining, two nuclei have been combining to form a stable element, that is C, with this liberation of energy. This E1 and E2, in both of the case, the energy is being released better. Now, how do you calculate this energy? Means delta E1 is equals to, in the fusion, it is mass of A plus mass of B minus mass of C. Whereas in the fission, it is mx, mass of your x minus mass of your y minus mass of your z into c square will give me the energy. If you are releasing the energy better, it is positive. If energy is supplied for the process, it is known as negative. Now, how do you calculate the Q value? Q value is equals to delta M into your C square. Clear?
Yes, sir.
Sure. Then I told you about your alpha, beta, and gamma. We just started with your alpha decay. When alpha decay is nothing but helium nucleus beta. An element XZA will decay into daughter nucleus, and by which whenever there is a decay of an alpha decay in this one beta, let's see if I'm writing here. In alpha decay, atomic number decreases by your 2 and mass number decreases by 4. So we are getting an alpha particle with liberation of certain energy. This energy is released in the always in the form of what beta? Kinetic energy. Now how do you calculate that energy? And Q is equals to delta M into C square. Delta M value is mx minus my minus m of your alpha particle into C square. So when daughter nucleus is being formed beta, whether the daughter nucleus Y, an alpha particle is also eliminated. This is your alpha particle. So alpha particle is moving in the front direction, daughter nucleus is moving in the opposite direction. So momentum is in the opposite direction. So initial momentum is equal to final momentum. So it is mass of your daughter nucleus Y, velocity of daughter nucleus Y is equals to mass of alpha particle into velocity of alpha particle. So if it's asking the velocity of alpha particle, it will be my Vy divided by m alpha. Directly, last time question 21, there was one shift, there was a question directly on this formula. What is the kinetic energy formula derivation? Kinetic energy of alpha particle is directly calculated with the formula Q into A minus of your 4. Okay, now?
Yes, sir. Yes, sir.
So up to this point, we have done in the last session of your class, isn't it?
Yes, sir.
Sure. Next one is beta decay. Next one is beta decay. Beta decay means elimination of an electron or maybe a positron, E plus. E minus and E minus is known as of your electron. E plus is known as of your positron. Okay.
Yes, sir.
In our syllabus, we are having 3 types of your beta decay beta. First one is known as of your beta plus decay. Next one is your beta minus decay. And third one is your K capped. Got it?
Yes, sir.
Beta plus decay, see what is happening is, a proton is disintegrating into your neutron with elimination of your positron plus of your neutrino. Nu means, nu is represented for your symbol neutrino. If it is nu bar, that will be called as of your what? Anti-neutrino. Okay, na?
Yes, sir.
So in beta plus, proton is being disintegrating into your neutron with the elimination of your positron because E plus, and with the certain amount of radiation coming in the form of your neutrino. If I'm writing this one in terms of your reaction, this is XZA. This is some nucleus. is been disintegrating into your daughter nuclei. Neutron ante atomic number decreases by your 1. Mass number will remain for me same, plus of your E plus of your nu. And how do you write the mass defect for this one, beta? That is nothing but mass defect delta M will be equal to your M into your X minus of your M into Y minus 2 times of mass of your electron. So Q value if he is asking, so Q will be equal to your delta M into your C square. Or else if delta M is in AMU, delta Q will be equal to your Mx minus of your My minus 2 times of mass of your electron, that is nothing but part, into your 931 MeV. Got an idea?
Yes, sir.
It is very important relation. Beta plus what is happening? A proton is being disintegrating into a neutron with the elimination of your what? A positron with the elimination of your positron and as well as of your neutrino. Clear?
Yes, sir. Yes.
In beta minus. In beta minus, what is happening is in the nucleus, a neutron is being disintegrating to become a stable with elimination of your proton plus E minus plus nu bar. E minus means what, beta? Electron. E minus is nothing but of your electron and nu bar is nothing but of your anti-neutrino. So in beta decay, in the beta minus or beta decay, this one is beta minus beta. Okay, so this is beta minus decay. Neutron is disintegrating into your proton with the elimination of your electron and as well as of your anti-neutrino. If I'm writing in terms of your reaction, XZA will give me a daughter nucleus, that is Y, whose atomic number will increase by 1 and mass number will be remaining same, plus with the elimination of your electron plus of your nu bar. So mass defect for this one is delta M is equals to mass of your nucleus, that is nothing but X, minus mass of your Y. Clear? So
Yes,
for
sir.
this one, if I'm writing the energy release, delta Q will be equal to your M into your X minus of your M into Y. In MeV, if it is taking, you directly multiply with your 931.5 MeV approximately. Clear?
Yes, sir.
Isn't it? So what is happening in the beta minus decay beta? Neutron is being getting disintegrated into your proton plus an anti-electron and as well as of your neutrino.
Yes, sir.
Yeah, sure. Next one is beta minus in the K capture. K capture means eating the part of a self. That means in the nucleus, it is surrounded by the electron in the K shell beta, isn't it? So if this is your atom, in the center part there is a nucleus Ze and it is being surrounded with your K shell. And in K shell there is one electron E minus. This is known as K shell, K, L, M and shells untai kada. If this nucleus
Yes,
is
sir.
eating the electron which has been present in the K shell, that process is called as of your K capture. K capture lo emautundante nucleus which is at the center will try to eat one electron which has been present in the K shell. So when proton has been reacting with you or eating this electron, we'll be getting a neutron and as well as of your neutrino. Okay, so proton when it is been eating the electron or when it has been reacting with your electron, it will give you the neutron plus of your neutrino. So that means XZA will get disintegrated into your Y by liberating energy in the form of your radiation. So whose atomic number decreases by 1, mass number will not change with the liberation of certain amount of energy nu. Got an idea?
Yes, sir.
So what is happening in a K capture beta? Proton is been reacting with your electron. So to form a neutron with the liberation of energy in the form of nu. That means XZA will give me the Y, Z minus 1 into A plus of your nu. So how do you write the mass defect for this one? Means delta M will be equal to again Mx minus of your My. Again, if this one is in AMU, you just multiply with your 931 point, this one. So energy liberated for this one is delta Q is equals to your, this one is delta M is Mx minus of your My into your 931.5 MeV. This is the way how do we write the K beta plus beta minus and as well as of your K capture. I'm sure we will be getting one question based on this one beta. Clear?
Yes, sir. Yes, sir.
I hope you got a clarity of revision of beta decay, everything. We are having three types of your beta decay, beta positive, beta decay, and as well as of a K capture. In the
Yes,
beta
sir.
place, what is happening is the proton is disintegrating to form a neutron with the liberation of your positron and 19 and positron and the liberation of neutrino. In beta minus decay, neutron is disintegrating into proton place of your electron and anti-neutrino. Whereas in the K capture, the nucleus is eating the electron which has been present in the K shell. So that process of eating the electron of its own is called as of a K capture. In the K capture, proton is reacting with your electron to form a neutron place of your and neutrino particulation. So in this one, the delta Q is given by the formula mx minus of my into 931 if provided mx minus my or delta m is in your AMU. So if delta m is in your AMU, delta m value is always calculated by the formula mx minus of your my or delta Q will be equal to this one. If it is not in AMU, how do you do it out beta? You multiply it with your C square. You multiply it with your C square. Okay, delta m into C square will give me the value of your Q. Is it clear? Is it clear?
Yes, sir.
Sure. The next one is right now for me. We have done with alpha decay, beta decay. The next one is about your gamma decay. Next one is your gamma decay. In gamma decay beta, there is no change in mass number and atomic number. It will be the same. It is just the liberation of what here in the form of your electromagnetic radiation. The energy is being coming out. Okay, like say
Yes, sir.
gives rise to a daughter nucleus Y, which is always with a star mark. The star mark will always represent it that it is in always your in excited state. It is always in your excited state and with the liberation either with your alpha particle or beta particle. Clear?
Yes, sir.
Now
Yes,
this
sir.
excited state daughter nucleus will become for me the stable by the elimination or by the emission of your radiation, which is called as of your gamma. Okay. X is
Yes,
becoming
sir.
Y. This Y is highly excited state, and during this excited state, either it may be leaving an alpha particle or beta particle. Again, this excited state will become for me your stable state. Now, this state of your Y is your stable state, beta. This Y is your stable state, and with the liberation of your alpha. That means ultimately X is giving you me the Y with the liberation of one alpha particle and as well as of your gamma particle. Clear?
Yes, sir.
So what is the mass number and atomic number beta? There is no change in Z and A. It will be the same. Clear beta?
Yes, sir.
In K capture, what is happening beta? I told you in K capture, electron is captured from where? Electron is captured from K shell of the atom.
Yes, sir. Yes, sir.
So that was about your radiations, which you should be remembering for doing the numericals related to this one. So I hope everything of these beta decay and beta minus decays have been clear for you. Any doubt in this one, you please let me know.
No, sir.
Okay. So complete nuclear physics, almost all the things have been revised there without any leaving part of this lessons. So that will be helpful for you to do while doing the numericals part of relation.
Yes,
Okay.
sir. Yes, sir.
I have done for you the screw gauges, beta.
Yes, sir. We have done.
Adokasar compulsory revise cheyana time dorkinappudu.
Yes, sir.
Don't skip that topic. That is really very important.
Yes, sir.
From here onwards, you need to daily revise your atoms. I told you now. Completely rows
Yes, sir.
PYQs అయినా చేస్తుండాలా. Atoms paina, dual nature paina, you need to at least try to do the PYQs related to that one. Okay, na?
Yes, sir.
So what is your today's role is beta? What you do is you try to complete modern physics problems atoms, atomic structure, nuclear physics. Okay, ఒక 10 questions
Yes,
అనేసి
sir.
dual nature పైన ఒక 10 questions, nuclear physics పైన ఒక 10 questions, and as well as of your atoms పైన ఒక 10 questions. ఓకేనా?
Yes, sir.
This one more topic is there, beta. That is about your radioactivity. So what do you mean by radioactivity, beta? Do you have any idea?
Sir, unstable అవుతుంది.
Disintegration.
Yes.
అవునా కదా? Unstable nucleus disintegrating is called as of your radioactivity, or directly మనం activity కూడా అనొచ్చు దీన్ని.
Yes, sir.
Activity కూడా అనొచ్చు. Isn't it? That will be the units for this one. That means the activity is directly proportional to your number of your active nuclei which have been present in a given sample. Isn't it? So the
Yes,
first
sir.
formula in this one I can write here right now. Rate of disintegration of number of nuclei present in your sample is directly proportional to your number of your active nuclei present in a given sample. అవునా కదా?
Yes, sir. Yes,
Removing the
sir.
proportionality constant, it is minus of your dn divided by your dt is equals to your lambda into your n, where lambda is known as what? Decay constant.
Yes, sir. Yes,
So
sir. Yes, sir.
simplifying it, we are getting one formula. N is equals to your n naught exponential to the power of minus lambda into your t. So this is the basic formula, the first formula which you need to remember. N is equals to n naught exponential to the power of minus lambda into t, where n naught is nothing but what, beta? Number of nuclei t is equals to 0. At t is equals to 0, the number of nuclei
Yes, sir.
present is represented by n naught. At some time t, the number of nuclei which have been present in a sample is represented by your t. And in terms of activity also, we can write this one as A is equals to your A naught exponential to the power of minus lambda into t. Activity,
Yes, sir.
and this one and now this will be one and the same. There is no difference in this one. Clear, beta? Clear?
Yes, sir. Yes, sir.
And next one, again, important formula in this one is right now for me, disintegration. Like say, for example, half-life of a time period, if I'm talking about half-life, represented by t half, or we represent it by letter capital T. Time taken to become exactly half is called as of your half-life.
Yes, sir.
Like say
Yes,
t
sir.
is equals to 0, I'm having n naught. T is equals to 0, sorry. T is equals to 0, the number of nuclei present in a given sample is, say for example, n is equals to n naught. Then at a time t is equals to your t half, this number of nuclei will become for me how much for me? Exactly n naught by 2. Isn't it?
Yes, sir.
Then again at a time t is equals to 2 times of t half, this will become for me n is equals to half of this one, that is nothing but n naught by 4. Again at a time t is equals to 3 half life,
Yes, sir.
this will become for me n is equals to, this is equals to, n is equals half of n naught by 4 is how much? N naught by 8. So like that, at some time t is equals to your n times of your t half, this value of your n will become for me n naught divided by 2 power of your n.
Yes, sir.
Isn't it? So at what time t is equals to this one? That means value of your n is equals to how much for me, beta? Value of your n, if I'm taking, n is equals to your t divided by t half. Avana?
Yes, sir.
So that is one important formula you need to remember. And direct formula for the t half is nothing but half-life will be equal to your ln of your 2 divided by your lambda. Or the value of ln 2 or log 2 will be equal to 0.693 divided by your lambda. There is one important formula you need to remember. T half is equals to 0.693 divided by lambda. And one more important term in this one is nothing but of your mean life. Mean life is nothing but the average time of the element or the nuclei, represented by letter tau, represented by letter tau. So tau is reciprocal of your decay constant, beta. So that is equals to your 1 by Decay constant means from this one I can write lambda is equals to 0.693 divided by your T half.
Yes, sir.
That means this will become for me 0.693 divided by T half. That means T half will go up. This one is value is 1.414 something into T half. That is the formula for your mean half-life. T is equals to tau is equals to 1 by lambda, or it is a T half divided by 0.693. Clear?
Yes, sir.
Sure. And one more very important formula in this which you need to remember is simultaneous decay. Like say for example, simultaneous decay. Now already in formula booklet పంపించాను.
Yes, sir.
అవి ఒకసారి తీసి రివైజ్ చేయాలి. Say for example, if x is disintegrating into y by decay constant of lambda 1 and x is simultaneously decaying into your, like say for example, some z by decay constant of lambda 2, then in that case the activity can be written as of your a is equals to your lambda 1 into your n plus of your lambda 2 into your n. That means a will be equal to your, right now if I'm writing into disintegration, a is nothing but minus of your dn divided by your dt is equals to here n common lambda 1 plus of your lambda 2.
Yes, sir.
So simplifying it, we are getting n is equals to your n naught exponential to the power of minus of lambda 1 plus lambda 2 into your t. So this is the direct shortcut formula to remember when we are having two decays directly. So n is equals to n naught exponential to the power of your minus of your lambda 1 plus lambda 2 into your t part of relation. Clear, beta? Is it clear?
Yes, sir.
So ఇక్కడ వరకు ఒకసారి go through చేసేసుకొని you try to do some PYQs. I'll also send you some good PYQs on this one. So what is your today's homework is I need you to complete at least 2020 and 2021 la atomic physics, nuclear physics and dual nature of matter పైన అన్నిటి పైన ఒక 10 questions అనే చేసి ఉండాలి. డ్యూయల్ నేచర్ పైన ఒక 10 questions, atoms పైన ఒక 10 questions, న్యూక్లియర్ ఫిజిక్స్ పైన ఒక 10 questions. అంటే 30 questions ఈ రోజున ప్రాక్టీస్ చేయాలి. ఏదో నాకు 1 hour టైం తీసుకోండి. అట్లీస్ట్ చూసేనే చేయ ప్రస్తుతానికి.
Yes, sir.
ఓకేనా?
Yes, sir.
Evening beta at 9:30 on same ID I'm doing some grand test paper for other students, for the MSET and NEET students. You can just join it for the sort of revision. Formulation and revision అయితుంటాయి.
Okay, sir.
Okay,
9:30.
Evening 9:30. Just sit, come and listen the lecture so that whenever some problems are happening, some formula based problems వచ్చినా కూడా నీకు రివిజన్ అవుతుంటది. మొత్తం ఫస్ట్ ఇయర్ సెకండ్ ఇయర్ సిలబస్ మొత్తం రివిజన్ అవుతుంది డైలీ ఫ్రమ్ 9:30 to your ఒక 40 minutes.
Okay, sir. Okay, sir.
Okay, take care beta. Bye.
Yes, sir. Bye, sir.